Afternoon to all of you. Um, Good afternoon to all of you. Myself, Ashish Kumar Srivastava, Assistant Professor in IT Department from IIMT College of Engineering, Greater Noida. Today, I am going to teach you the computer organization and architecture. So, my first topic would be um, introduction, functional unit of digital system and their interconnections. And second is the buses and buses architecture, types of buses, bus arbitration. What do you mean by the bus arbitration? And registered memory, bus and bus memory transfer, process organization, stack organization, and last one is the addressing. So that here we start our first topic, functional unit of digital system. So what is the functional unit? So functional unit of digital system. A computer organization describes the function and design of the various unit of digital system. A general purpose computer system is best known example of digital system. Our other example including telephone switch exchange, like in using in BSNL office, digital voltmeter, digital counter, electronic calculator, and digital display. These are known as are also known as the example of digital system. Computer architecture deals with the specification of the instruction set and the hardware unit that implement the instruction. Computer hardware consists of electronic circuit, display, magnetic, and optic storage media are also communication facilities. Functional unit are the part of CPU that perform the operation calculation called by the computer program. And here, functional unit of the computer system are the part of CPU that is known as central processing unit that perform the operation and calculation called by the computer program. A computer consists of 5 main components, namely input unit, central processing unit, memory unit, and ALU. And ALU means arithmetic and logical unit, control unit, and output unit. These are the basic 5 types of functional unit of digital system we have used. So first of all, what is the 5 types of computer main component, like input unit, central processing unit, memory unit, ALU unit, and CU unit, and output unit. Here are the function of the functional unit, diagram of the functional unit. First one is the input unit. Second is the storage unit, or it is also called memory unit. Then control unit, and then arithmetic logic unit. Control unit and arithmetic logic unit are part of the central processing unit, which is also known as CPU. And the last one is the output unit, and then show the result. When the program or data enter into input unit, then pass over the storage unit, means pass over the memory unit, and then memory unit also pass over the control unit, and control unit pass to the arithmetic and logical unit to perform the operation, and then also pass over the control unit, and control unit then when we have done his operation, its operation, then pass over the output unit, and output unit then show our results. Let's suppose, for example, we have write a program of addition of the two numbers, like A is equal to 3 and B is equal to 5. We have write down in C programming, like just like int A is equal to 3, int B is equal to 5, int C is equal to A plus B, print C, print F, and then scanf, then get CH, and then so on, so on. So we have stored the resultant in C is in variable which types are integer, like C is equal to A plus B, and C means C holds the value of A and plus B, means C is the 5 plus 3, C is equal to A. C stored the value of A and B in storage. We have write down this type of program using input devices, and then when we have write down the program or instruction passes to the storage memory or memory unit, then memory unit passes to the control unit or arithmetic unit. Arithmetic unit perform this operation C is equal to A plus B, and then passes over the control unit, and control unit passes to the output unit, and output unit show the result C is equal to A plus B, means C is equal to 8. This here are the passes of the functional unit. This is the diagram of functional unit we have described. Now here we have to go by one by one, like the input unit are used by the computer to read the data. The most commonly used input device are keyboard, mouse, joystick, trackball, microphone, and its extra. Next, central processing unit. Central processing unit, CPU. We have know about the CPU. Central processing unit, commonly known as CPU, as referred to the electronic circuitry with a computer that carry out the instruction given by the computer program by performing the basic arithmetic, logical control and input-output operation specified by the instructor. CPU play the important role of whole function unit. CPU, in CPU, there have two parts. The first one is control unit, and the second one is the ALU, arithmetic and logical unit, which are also considered as a CPU, central processing unit. Then now, we have consider about the memory unit. The memory unit can be referred to the storage area in which the programs are kept, which are running, that contains data needed to the running program. The memory unit can be categorized in two ways, namely primary or secondary. We have also known about the memory unit or storage memory, storage unit. These are the two types of memory unit. First one is the primary memory, and second one is secondary memory. Primary memory means RAM, and the secondary memory means hard disk, hard drive, pen drive. We have storage in, we have used for storage purpose in memory unit. So memory unit are used for the storage of program or instruction in primary memory or secondary memory. So let's another one is the arithmetic and logical unit, ALU. ALU is the very important role in CPU. Most of the arithmetic and logical operation of computer are executed in ALU, arithmetic and logical unit, to processor. It perform arithmetic operation like addition, subtraction, multiplication, division, and also logical operation like and or not operation. It means ALU perform both type of operation, arithmetic as well as logical. Here are the two combination of arithmetic and logical unit. So it is called ALU, arithmetic and logical unit. So let's suppose we have let's just discuss about the previous example of addition of the two number like A is equal to 3 and B is equal to 6. In storage about in C, then 3 plus 6 is equal to 9. C stored the value of A and B in C. Here are performed by the ALU, arithmetic and logical unit. Then control signal passes over the control unit. The control unit is the component of computer central processing unit that coordinate the operation of the processor. It tells the computer memory, arithmetical logical unit, and input and output device how to respond a program instructor. The control unit is also known as nerve center of computer system. Control units play a very vital and important role in CPU. It is play the very important part of CPU. It is the nerve center of computer system. The control unit are the mainly passes the control signal as well as timing signals to the input devices, output devices, arithmetic unit, and memory unit for given this to perform his operations. The next one is the output unit. The primary function of the output unit is to send the proceed result to the user. The output device display information in way user can understand. The output devices are the piece of equipment that are used to generate the information on other response processed by the computer. These devices display information that has been held generated within the computer. The most common example of output devices is like monitor, projector, printer, etc. For example, in previous diagram, when the instruction or program passes to input and then storage and performed by the CPU and then comes over the output unit, that output unit show our results like C is equal to A plus B. So the output unit is also as monitor, printer, and projector. So now we have considered about the second topic is buses and bus architecture. So first of all, what is bus? What do you mean by bus? Bus is a path, or bus is the communication path provided between the components like CPU, memory, input, output devices, uh, etc. A bus that connect major component, CPU, memory, and input, output devices of a computer system is called system bus. A bus is a set of electrical wires, lines that connect the various hardware component of computer system. It works as a communication pathway through which information flow from one hardware component to other hardware component. Bus architecture is as shown in figure below. Here are the figure of bus system bus architecture. So first of all, we have discussed about the bus. So what do you mean by the bus? Bus is a line or wire, or bus is the path to provide the communication between the CPU, memory, and input output device. So here, the system bus, we have shown the in figure system bus architecture. The system bus architectures are the three types of buses we have used. That is, first one is the control bus, second one is the address bus, and last one is the data bus. Control bus are the bidirectional, and data bus are bidirectional, but address bus are unidirectional. These are the three types of buses are used in system bus. Means system bus are used by you are described using the three types of bus: control bus, address bus, and data bus. These buses are connected to the CPU, memory, and input. CPU are connected with the data bus and connected with the input output devices. Memory are also connected with the data bus. CPU also connected to address bus. Input output devices also connected to address bus. Memory are also used the address bus. Control bus are also used by the CPU, input output devices, or memory bus. So here are the architecture of system bus architecture using the CPU, memory, and input output devices. Here, the types of buses. How many types of bus? There are the three types of buses: data bus, address bus, and control bus. System bus contain three category of lines to provide the communication between the CPU, memory, and input output, named as data bus, address bus, and control bus. There are three types of bus: data, address, and control bus. Let's describe one by one. First one is the data bus. As the name suggests, the data bus is used to transmit the data or instruction from CPU to main memory, CPU to memory input output, and vice versa. It is bidirectional. The bit of data bus refers to the number of bits the bus can carry at a time. Each line carries one bit at a time. So the number of line in data bus determine how many bits can be transferred parallelly. Now, address bus. As the name suggests, the address bus is used to carry the address from CPU to memory unit. It is used to identify the particular location in memory. It carried a source or destination. It is also used as a source to destination address, where to store or from where to retrieve the data. It is unidirectional. Address bus is unidirectional. For example, when the CPU wants to read or write data, it sends a memory read or write on the control bus to perform the memory read or write operation from main memory, and the address to the memory location it's sent to the address bus. If CPU wants to read data storage in memory location 4, the CPU send the value 4 in binary on that address bus. It means we have let's suppose we have want to use that addressing map in future. We are discussing about the addressing of addressing mapping using the address bus. We have used from source to destination and destination to source using the address bus for using the source and address. and destination address. Now, control bus. As the name suggests, the control bus used to transfer the control and timing signal from one component to other component. The CPU uses control bus to communicate with devices that are connected to the computer system. The CPU transmit different types of control signals to the system component. It is bidirectional. Typically, control signal hold by control bus memory read data from memory address location to placed on the data bus. For the control bus are playing very important role in these types of in the system bus. Control bus are provide the controlling signal and timing signal to one component to other component. Now, what about the system of bus arbitration? What do you mean by bus arbitration? What do you mean by arbitration? So bus arbitration is the procedure by which the active bus master access the bus, relinquish control of it, and then transfer it to different bus checking process unit. A bus master is a controller that can access the bus from a given instances. A conflict could occur in multiple DMA controller to other controller, or process attempt to access the common bus simultaneously at only one is permitted to access. Bus master status can only be held by one processor or controller at once. By coordinating the action of all the seeking memory transfer, the bus arbitration method is used to resolve this dispute. These are two approaches to use the bus arbitration. We have discussed previous about the bus types of bus. We have discussing the three types of bus, that is known as address bus, data bus, and address bus, data bus, and control bus. Now, we have in system bus arbitration, when the bus we have when the all the functional unit components are connecting to communicate to each other using bus, when the all are using the same line type of system bus, they approach to communicate to each other on priority basis, then the bus arbitration are used. Bus arbitration means bus master. It is play a important role to controlling the buses for priority basis. Which type of devices bus master has decided, which type of device on higher priority or lowest priority, which type of bus are considered, which type of requested to access, which type of grant to access the devices, device 1, device 2, device 3, device 4. Like let's suppose we have using the system bus for communication, and here are the n number of devices. Like device 1 is a input device, like device 2 is input device, like device 3 is output device, like device 4 is output device, and so on. So all are access to same type same time to communicate to the each other on the system bus. So bus arbitration play an important role. As a master bus, they have decided which type of priority is highest or which type of priority is lowest. So we have two type of approaches using the bus arbitration. First one is the centralized bus arbitration, and second one is the distributed bus arbitration. Centralized bus arbitration is the same concept. It is the in center bus arbiter, which the center bus arbiter play a controlling to each other, in which the necessary arbitration is carried out by the lone bus arbitrator. It is decided which types of device 1 or device 2 or device 3 and device n number of n devices are connected in system bus, which is first priority and which is the highest priority, and which is the next highest priority, and which is the next, and so on, and which is the lowest priority. The centralized bus arbitrator play a master bus controller to giving the priority. And distributed bus arbitrator, in which every device take the part is choosing the new bus master. A 4-bit identification number is allocated to devices on the buses. The create ID will be decide the device priority. Now, let's discuss the centralized bus arbitration methodology. Here are the three methods of centralized bus arbitration which are listed below. First one is the daisy chaining method. Daisy chaining method is very popular for centralized bus arbitration methodology. It is very important point of view. So daisy chaining method is what? It is the simple and cheaper method where all the bus master use the same line for making bus request. The bus grant signal serially propagate through each master until it encounter the first one that is requesting access to the bus. This master block the propagation of the bus grant signal. Therefore, any other requesting module will not receive the grant signal and hence cannot access the bus. During any bus cycle, the bus master may be any devices, the processor, or any DMA controller unit connected to the bus. Now, here are the diagram of daisy chaining bus arbitration scheme. In daisy chaining method, bus arbitrator play a master of bus. Here are the device 1, device 2, device 3, device 4, device 5, and so on. And last one is the device N, which is the lowest priority. Device 1 is the highest priority. Device 2 is the next higher priority. Device 3 is next, and device 4 is next, and so on. And the last one is the device N, which is the lowest priority. We have arranged this type of devices to the higher priority to lower priority. Bus arbiter grant the first highest priority device 1 to access the master bus, and then grant the second device, and grant the third device, and grant the fourth device, and so on. It provides the last grant for device and for lowest priority. Device 1 highest priority request to the bus arbiter. Device 2 is also request to the bus arbiter. Device 3 is also, and device 4 and last device and lowest priority is also request to the bus arbiter. And then and device 1 also released, and device 2 also released, device 3 and device 4 and last device N is also released. Bus arbiter had decided device 1, which is the highest priority, is grant first, then next highest priority is grant second, and then next higher priority is grant third, and so on. And last, the next and lowest higher priority is granted in the last. This is the method of daisy chaining bus arbitration scheme. It is very simple method. It is advantage. It is very simple method for bus arbitration centralized scheme. Disadvantage is cannot assure fairness. A low priority device may be locked out indefinitely. The use of the daisy chaining grant signal also limit the bus speed. Here are the topic we have discussed about discussing the centralized bus arbitration method, daisy chaining, and the next one is we have discussing in next lecture. So we have discussing about the distributed method. In distributed arbitration, every devices are in distributed manner. There bus arbitrator, there is no any central bus arbiter play. Each devices has a use as a master bus. They have using the bus arbitrator. Every device has a bus arbitrator or master bus in distributed method. Now, any query? We have discussing about the next topic in next lecture. So any query in this topic today? So thank you so much for watching me and for listening me. Thanks.